10.3 notes, polar coordinates, page 4. I'm going to change this up just a little bit. We're going to go through the math on this page, and then I will create a separate page, a separate recording to talk about graphing these on the graphing calculator. Trying to load it in here made this super long and cumbersome, and I definitely don't want to do that. So we'll take a look at the math part here. We'll convert from rectangular to polar. We'll take a look at a couple of graphs, and then we can look further at the graphing calculator in another recording. So let's start with example 7. We want to graph this equation, x squared plus y squared equals 9. Hopefully you remember from college algebra looking at it like this. X squared plus y squared equals 3 squared. We know that is a circle. We know that the center is at 0, 0, because I have x minus 0 up here, y minus 0, and I know my radius is 3. So I'm going to plot that. There's my center 0, 0, up 3, down 3, to the right 3, to the left 3. And if I have, there we go, circle, radius 3. Mostly hits my points. Use your imagination a little bit. Okay, so let's talk about how we write this. Let's see if we can color code here too. So now we're going to write that equation in polar form. And we're going to start by using this fact here, x squared plus y squared equals r squared. I'm going to use that to just replace that entire left-hand side and write this as r squared equals 3 squared. And then because I really want the equation as an r equal, I'm going to square root both sides. I get r equals plus or minus 3. And I can separate this out into two separate equations. We can graph those both and see that they look exactly the same. So this does not have an angle involved. Let's see how we graph this on the polar grid. Keep in mind, from my center, each of these circles is 1 unit. So there's my 1, there's my 2, there's my 3. If we're saying that r equals 3, so 3 out, 3 up, that is right here. Pulled it off a little, otherwise it sits right on the line and you can't see it. So there is the equation r equals 3. Notice that if I were super organized and would have made these graphs consistent with each other, those circles would have been the exact same size. But you can see how we can graph this in either rectangular or polar. Now, the one thing that I do want to point out, if I were going to use the graphing calculator to graph my rectangular form, we're going to move back over here to the left. I have got to solve that equation for y, right? In the graphing calculator, it's got to go in as y. Nope, 9 minus x squared. Let's back that up a little bit. Y squared equals 9 minus x squared. I just moved that x squared to the other side. And y is going to equal either plus or minus 9 minus x squared. So to graph this on the graphing calculator, I'd have to graph y equals the positive square root of 9 minus x squared and y equals the negative square root of 9 minus x squared to get both halves. Keep in mind, if you're graphing this in Desmos, Desmos doesn't have a problem with both x squared and y squared, so you're good. Example 7, we want to rewrite the equation x squared plus y squared equals 6y. And we're going to use a couple different things. I got x squared plus y squared equals r squared. I also have y equals r sine theta. And so I am going to replace on both sides. My x squared plus y squared part becomes r squared. My y becomes r sine theta. I want to be able to solve this for r, so I want to put everything on the same side. R squared minus 6r sine theta equals 0. I can factor an r out. One thing to notice is that r equals 0 is just the point 0, 0. Okay. Once I take a look at those graphs, I realize that that point 0, 0 is already on this graph, r minus 6 sine theta equals 0. So there is that equation rewritten in polar form. Again, we can discard the r because that's already duplicated in the r minus 6 sine theta part. Example 8, we're going from rectangular to polar. I have an x in there, which I know is r cosine theta. I have an y in there, which I know is r sine theta. And so I'm just going to replace r sine theta equals 3 times r cosine theta plus 2. If I want to solve for r, I need all the r's on the same side. So I'm going to subtract that 3r cosine theta. I can now factor, left the theta out. Factor out my r. I get r times sine theta minus 3 cosine theta equals 2. I can divide both sides by sine theta minus 3 cosine theta. And I get r equals 2 over sine theta minus 3 cosine theta.